All right, welcome. So welcome back. We're doing 9.2 Calculus with Parametric Curves. We actually already talked about some of this stuff, but we'll actually really get into it. So first thing is, let's say you have a parametric curve in the plane. So you have x of t and y of t are given. And you want to find dy dx. We actually already did this, but we're revisiting. So dy dx is dy dt divided by dx dt. Okay. Now let's say we also asked for the second derivative. d2y dx squared is going to be d dx of dy dx. Okay, and so when you do this d dx, remember there's a t in there. So what you're going to do is that's going to be d dt of our dy dx divided by dx dt. And again, in some sense, not the best sense, but in some sense, this dt cancels. Okay, so let's take a look at a problem. Let me see here. Okay, so let's take and let's find the equation of the tangent line to the point corresponding to t equals 3, and we're given x of t equals 2t squared plus 1, y of t equals 1/3 t cubed minus t. Okay, so we actually have two different ways to look at this. Okay, there's two different ways to look at this. There's this way that we're doing today, and then there's the way that we did in the stuff in the last set of videos. So let's do them both. Okay, first approach, both approaches, we're going to need to find x of 3 and y of 3. So let's do that first. X of 3 is going to be, well, x of t, no, sorry, x of 3, sometimes I get ahead of myself. X of 3 is going to be 2 times 9, 18 plus 1 is 19. Y of 3 is going to be 27 divided by 3 is 9, minus 3 is 6. So the point at which we're doing this is 19/6. Okay, next, the first thing we're going to do when we do this way, we're going to find dy dx. Dy dx, remember, is dy dt divided by dx dt. Okay, that's going to be what? T squared minus 1 divided by 4t. And we're going to do this because we want to do this at the point we're doing it at t equals 3. That's what that means. Okay, so that's going to be 9 minus 1 is 8 in the numerator over 12 reduces to 2/3. So now we are basically we're finding the line through 19,6 with slope m equals 2/3. Okay, so y minus 6 equals 2/3 x minus 19. Okay, this is the equation of the tangent line. That's the first approach. Now, that's the approach that you would do in chapter 9. But I've taught you more than that. So let's look at the other way of thinking about this. Okay, we have a point. It goes through 19,6 again. Okay, but also we have a direction. We have a direction in terms of a vector. Okay, so our direction is, in terms of a vector, we have, well, we're going to take the dy or dx dt. Let me write it this way. We're going to do that at t equals 3. Okay, so derivative of x is 4t. Derivative of y is t squared minus 1. Okay, at t equals 3. So that's going to be 12 comma 8 again. Okay, so our line, if we want to think about it as parametrically, we could say x of t is 19 plus 12t. Y of t is 6 plus 8t. And this is a parametric version of this line. Okay, it goes through 19,6, and the direction, you could also sort of, let's say we reduce it. Let's reduce it so that this 8 is 1. So we would divide both sides. We would divide both of these by 8. So we could write this as 19,6 plus t. And now the direction, it doesn't matter how long it is because you need to just go out farther in t, right? So divide both sides by 8. 12 divided by 8 is 2/3. No, 3/2, sorry. Okay, we could also, let's say we could have divided, it's actually better, let's divide the x by 12. So that would be 1, and that would be our 2/3. So that's sort of how you see the connection between them, okay? For every one step that you go in x, you're going to go 2/3 in y, which is the same thing as a slope, okay? I wanted you guys to see that sort of connection. All right, we'll be back with integration and area.